Hi, good afternoon once again. And can one of you confirm you can hear me?
Good afternoon, sir.
Yeah, great. Okay, thank you for joining. And today we are going to cover the other aspect of AI that we discussed last time. We said we'll talk a bit of machine learning in next few lectures, and especially machine learning as a technique of AI. And so first, the behavioral or psychological aspect of this learning. So I'll share my screen and then start. Okay, so as the slide says that we are trying to, why we are studying the behavioral or psychological perspective of intelligence is because the machine learning basically tries to mimic this. So here I have written two things in bracket. If you read it without the bracket terms, it is learning as an instrument of intelligence. So it appears once we discussed earlier in the classes, as per the terminologies we discussed, we said probably intelligence cannot be trained, but intelligent tasks can be performed by people who may not be originally or before that learning, may not be behaving in an intelligent manner. But after the modification of behavior or after the learning, they might do those intelligent tasks, even maybe sometimes better than otherwise intelligent people. So this is what is about humans. And also if we look at the same ideas we apply, if it can be machine learning, which can be used as an instrument of artificial intelligence. So today I'll briefly just take an overview of what the psychologists or non-computational scientists have thought about. The psychologists have long tried to make learning as a science. And that's why they have incorporated a number of ideas which are very useful. And they have been already used in machine learning in a number of ways. And they are also useful to develop new methods which have not yet been developed. And we will discuss with you what is your perspective, because many of these things we we use it in our daily life without actually knowing them. So first of all, what is learning? Can somebody define what is learning? Whatever is your perspective, what you think is? Yes, Aditya.
The broadest terms, I think it is the acquisition of information that changes your behavior in some sense.
The two things, acquisition of new information and changing of behavior. Both of them may not be learning. So
I would say just acquisition.
If we keep on drawing analogies with computers, so adding new information would be like putting more information on memory. So putting some information and then utilizing an array of memory cells and then putting more information. So
in computer terms, I think it would be like storing more information on memory, then deducing some things from it, and from that deduction, changing the way in which program works. Some program on the
system. Putting new information may be there, but you might add information without actually learning anything. So like in some sense, you can say that having more information for a human being is more like having more of experiences. So as we grow, we come across several environmental inputs. And after those inputs, we can say that more information has been added up, even if we remember each one of them. Now, how we utilize that in our interaction with the environment to be able to do our tasks better in the future. We might have to do all that we have studied so far about the artificial intelligence and the methods. One of them we earlier did was kind of a lookup table. We create a reference table, and for every action sequence, I say, if this is my action sequence, a percept sequence, for this percept sequence, this is my outcome. So in this way, if that is how I act, can it be considered learning? It was discussed that it was not considered intelligent at that time. But if we come back here to this point again, from the perspective of learning, that a machine is experiencing more and more of percept sequences, as percept sequence gets longer. And In the process of this, an individual machine, or equivalently a human being, is trying to develop more and more mapping. So do you think such an act, when the new mappings are being created from an action sequence to an action, percept sequence to an action, this is the process of learning? This is just adding new information without probably learning, because learning should also involve another level of kind of generalization and abstraction. We'll come to that. Generalization is a fundamental concept of machine learning also. Your machine learning models may be very accurate and may perform very well, and may have no generalization at all. So can you call such a machine learning model, which learns a lot, which is capable of giving inputs and giving very high accuracies during your training stages, can you call such models intelligent? And will they work on a new data set? If they don't work on a new data set, we say in machine learning language that the model has failed to generalize. And there are techniques to test whether the model has generalized enough or not. So the same way, human brain, when it experiences new environment, it goes through new environment, new environmental inputs are given, then it may or may not learn. But then in the case of human beings, it is defined as three things particularly, not just ability to do work, that in terms of either knowledge. So like we are seeing new experience, so we are adding new knowledge. So learning is the change in this knowledge. We had knowledge about X number of things, and now after I have experienced my environment, or I have been exposed to new knowledge, my knowledge size grows. But this is more equivalent to the memory, information going into the memory, which is not useless, which is useful, because based on that knowledge only you can act. Second is the change in the behavior. I behaved in one way and I behave in the other way. That is, for instance, we learn social skills, we learn etiquettes, we learn how to do certain things in certain environment, how to behave to our elders, how to behave to our youngsters, and how to act to our friends. We learn this behavior. So this does not come inherently in us. Over a time, we learn. So behavioral changes. So even if I know that how the world is behaving and how the world is acting, so my knowledge may grow, but my behavior may not change. But both of them will be considered learning as far as this definition is concerned, which the source of this I have put on this slide. I'll share with you these slides, just a few slides that I have today to discuss, because mainly it is a discussion between your own thoughts and trying to channelize them. And the third is the understanding. So can you figure out what is the difference between the change in understanding and change in behavior?
Behavior would entail some sort of action, but one can understand things and not act on it.
Yes. So one may understand something, but may not translate into action. So just the understanding is a kind of a latent change in an individual, in your brain. And how it happens, people have said it as per this definition here, is this happens through making new connections between new information and the existing knowledge. So we already have an existing knowledge. We have previously been exposed to certain environment, and therefore we know that if I touch fire, my hands will burn. This is my existing knowledge. My existing knowledge also may be about what color is likely to be the color of fire, which color of fire may be more intense than the other, what shape of the flame may be, or what part of the flame may be. So this may be my existing knowledge. And I make new connections by knowing more about it through new experience. I may not know about color, so maybe I knew only the flame and burning sensation relationship, but I did not know the color relationship. So next time I know the color relationship, so my knowledge will now be represented as a 3-level information: color, flame, and the impact on the likely impact. So these are understandings, and this is a knowledge that is getting added up. So basically, any new information that comes will be connected to an existing knowledge. But this is one way of looking at the learning process. And that is why I would take a look at what are the existing theories of learning. And these theories of learning, as I mentioned them, I would keep on reminding you how they have been incorporated into machine learnings, and then I will come to formal definitions of machine learning. But before we proceed to that, yeah, Aditya.
I had a question in this regard.
Yes, please.
Shouldn't here it says that it is the change in knowledge, behavior, understanding when between and making connections between new information and existing knowledge. So there could be two cases here. Either it could be inductive in the sense that whatever I know, whatever the generalization I have about something, and the new data that I receive, I translate that data into something that confirms my generalization. And the second would be whatever knowledge I have, the new data that comes can in some way contradict what my generalization was about the given environment. So my question is, because at any given instant, the existing knowledge would always be greater than the new information that comes in.
Not necessarily. Yeah, existing knowledge, of course, existing knowledge receives the environmental inputs only in an incremental way.
Yeah.
We are not certain. So since the environment is being exposed incrementally, our existing knowledge will also modify itself in an incremental way, but not always.
Yeah, but that is my question. That is what my question is, that new information essentially would be sparse in relation to the one that we actually hold at.
Now I understand what you try to.
What the weight should be assigned to that information so as to change our generalization.
Yeah, that is a very excellent point, and actually it will connect to the theory of one theory of learning, which is called cognitivist theory of learning. I'm actually coming to in the next slide about it. But this is a very important point. It gives you, when I say that learning is a process of connecting new knowledge to an existing knowledge, you wonder that in the beginning we have very little knowledge, and therefore there is very little scope of creating connections. And perhaps that puts a limit on how much we can learn. That bothers you, right?
Yeah.
So yes, so it is also, it should not be just connections to the new knowledge. That is absolutely right. This should also be ability to change our existing. So this, when I make new connections, my existing knowledge, they get incorporated into my existing knowledge. So incrementally, my existing knowledge is growing, and my new connections will be formed with the existing knowledge of that particular moment. Existing knowledge is not static. So that particular concern is addressed here. So I cannot drastically learn all of a sudden lots of things. I have certain kind of, you can think of like a core nodes, and the new nodes are getting added up, and the network is growing in size. So this is a constantly growing network of nodes in some sense. You can think of it this way. And the connections means new nodes are getting added up. So not only the new nodes are just kind of new information, and the connectivities between the nodes that you are adding are the connections that are provided by the learning process. So if you get a lot of dots, that is like you have a graph, a lot of dots on the, a lot of points, a lot of nodes on the graph, but no connectivities. That means learning is not happening. Just the new nodes are getting added up. In this way, you can connect, you can understand this. Does this address your point, Aditya?
But it could also be the case that the new nodes that come in and the connections that they serve with the existing ones are in a way that contradicts the ones that are.
Absolutely, they do contradict. And thank you for noticing it early. Yeah, they do contradict, and this is called the state of disequilibrium. I'm coming to that in the next slide, and I'm glad that you raised it early and you could see it early. This is the whole theory of how we develop and learn through the process of assimilation and disequilibrium, and the disequilibrium then ultimately leads to accommodation. I'll come to this point, exactly your point that you are trying to say. But before that, I'll talk about the other three theories of learning, and then come to this point that is on this slide. You can notice that this is written in the end. So this is the point that you are making, and we'll discuss this clearly. So mainly learning has been studied by psychologists for the purpose of educational training and teaching. So machines also in a way are taught. So how do we teach our students better? So as a teacher, I should know how my students learn, then only I can teach them better. That's why people were interested in learning about learning process itself. And then, sorry for the spelling mistake in the first line. So behaviorism is modification of behavior by the term called reinforcement. And you may have heard in machine learning also, there is something called reinforcement learning. How many of you have heard of it?
Yes, sir. It is one of the paradigms.
Yes. So this term reinforcement was used long ago in 1930s. Actually, this history of learning theories is not very old, you see. Only in 20th century, people have started to understand the science of learning. So in 1930s, the different scientists, Watson and Skinner, are the two prominent psychologists, behavior scientists, who tried to understand the process of learning. And they were very keen to establish the psychology as a science. And that's why they try to quantify a number of things. So now, one of the experiments, even before this, was an experiment. I may have talked about it earlier. I don't know. The experiment that was conducted by a Russian scientist, Pavlov. He conducted an experiment on dogs. Did we discuss this earlier? I'll just repeat it. Even if we have discussed it, it may be a repetition, but just to put this in the current context. So the experiment was that they put a dog in a machine and they could measure the saliva that is produced in the mouth of the dog. And then they give some food, they present some food to the dog, and some saliva is produced. So they could measure the quantity of saliva and therefore say that the response is happening. Food is, they call it stimulus, and the response that is generated, the production of saliva, is a response. So there is a stimulus and there is a response. So this is called the primary stimulus. Whenever we see the environmental input, on that we respond. We also do it many times. We receive an input, and based on that, based on our previous knowledge or my intrinsic instincts, whatever, some response is generated. So this Pavlov went ahead and tried to see whether he can connect this stimulus with a new stimulus. So what he did was he first rang a bell, then presented the food, and then the saliva was produced. So this bell, he called it a secondary stimulus. So when the first stimulus, the primary stimulus, was presented alone, saliva is produced, so condition is more natural. So in the beginning, when you ring a bell, the dog does not learn whether it has anything to do with the food. So therefore, no response is generated or no saliva is produced. Then over a time, if after several efforts, when every time a bell was rang, food was presented. So what the scientist is trying to do here is they're trying to link the primary stimulus with an artificial stimulus, with a new stimulus, secondary stimulus, as you can call it. So after several experiments, it was found the dog learned to produce saliva even when the primary stimulus was not presented. Just the ring of the bell, because ring of the bell was connected every time, it was associated to the presentation of food. So even if food was not presented, the presentation of the bell itself was sufficient to elicit a response. So this type of behavior is called conditioning. So the response gets conditioned. And as a result of conditioning, this is a kind of learning that happens. Can you tell some of your own life experiences to relate this experiment to your learning through conditioning? Or your learning of other people around you? You understand the experiment well? Everybody understands? Can you all say that the experiment that I just described, have you all understood?
Yes. I guess one incident that I can connect it with is like one of my friends used to play the mouth organ very prominently whenever he went around in 7th grade, I guess. So whenever now I hear, I don't know if it's correct, but whenever now I hear someone play mouth organ, I get the sense that he's coming.
Yes, excellent. Yes, can other people also describe some experiences where they have learned to respond to secondary stimulus when it is not present. There are umpteen examples all throughout our life. We learn through these kind of conditioning. We are all conditioned. It is so difficult to come out of our conditioning. Many of our prejudices are based on conditioning. Many of our positive things are also based on conditioning. People may be scared of some other people, even though they have nothing to be scared of, because they have been conditioned. So just think of these experiences. I think it's not difficult to recall many experiences where conditioning happens, and a lot of us learn through conditioning. So this is the classical way where people originally started thinking about learning through conditioning. And this was then further how Skinner modified.
Is how they train pets too?
Say again?
Isn't this how they train pets, dogs?
Yeah, actually, yeah, pets, I will explain now. Pets, yeah. So pets also, actually, a lot of this learning process has been implemented on training the pets and training the wild animals also. So a lot of that goes there. So yes, conditioning is used there, but actually more than conditioning, what is more effective is the reinforcement-based learning, or the so why I mentioned conditioning is this is also called the reinforcement-based learning. It is also called the what is it called? Instrumental conditioning. So conditioning is kind of binary. You just connect one stimulus with another stimulus. So these connectivities can be generated, and these are raw connectivities that can be generated. And they cannot be used for training some very, very big tasks. So then these researchers such as Watson, Skinner particularly did some experiments on instrumental conditioning. And how this was done was through a process of reward and punishment. So he originally did these experiments on pigeons. So in pigeons, if they want to train them to do a particular behavior, so instead of just linking them to the final goal, even if the subject is coming closer to the goal, they give them some reward. So this reward kind of becomes your conditioning. So in the earlier example, when we were talking of the food and bell, the food was the reward. So in a process of conditioning, the food reward was connected to the bell. In these experiments that were done on pigeon, and later on they have been implemented in the school curricula, that if a student performs correctly, you reward him, but you also reward him even if his answer is partially correct. So initially you keep on changing the goalpost. Initially reward him for 10% correct, then reward him not for 10% correct, 20% correct, and then 30% correct. In this way, you can incrementally be more demanding and gradually instrument a change in the behavior of your subjects. So this is also used in zoo and other places to learn for training the animals, because if you want to train animals to do something very big, they will not be able to learn through the process of raw conditioning. So this kind of systematic reward and punishment are used. In our lifetime, again, can you give me examples of how we learn through this process of reward and punishment and incremental reward and punishment? Can you think of any persistent reward that makes us learn certain etiquettes?
Persistent rewards in the sense that they are not changing.
No, persistent means rewards being presented to you persistently over a period of time under certain conditions.
It would be in the case of performing well in academics. So that we are rewarded, but that too, that there is a sense of incrementalism in that if suppose one performs consistently, suppose say gets 90% of the grade or 91%, and if he does it 2 or 3 times, then that doesn't meets the criteria,
So
then he has to go over 90.
if you get high marks, so how does it modify your behavior? What do you learn through that reward?
The reward is respect and affection by our peers and parents and teachers.
Yeah, so it is not marks in this case. So that is the reward. That is a reward actually. That is equivalent of marks. So if you are being praised, or there is a social approval, or the affection, or as you said, or kind of compliments. So these all are rewards for us to learn certain things. So if we do certain things well, so people will say, oh, what a nice boy he is. And these kind of rewards make us repeat that behavior for which we have been appreciated. So the appreciation and approval of our behavior is a kind of a reward. And through the process of reward and punishment, but punishment does not mean physical punishment. Punishment, maybe you did something and somebody will say, what a stupid guy he is, or how rude is he. So we learn through these rewards and punishment, the social approvals and disapprovals, appreciation and criticism, and positive and negative commentaries. We try to learn how to behave. That is how a child learns to behave, to say, to be respectful to elders, to not go in public without dressing properly. All these behavioral aspects, they learn through the process of reward and punishment. So each one of us knows about this kind of reward and punishment. So now psychologists actually have also studied whether this is a good way of learning. This is a philosophical question. So I just make a couple of remarks on this. Do you think, is it a good idea that to train or to teach through a process of reward and punishment?
In some contexts, not as a absolute sense.
So for instance, I want my students to come on time. So I decide to kind of introduce a reward and punishment system. If they come on time, I'll say, I'll give you marks if you come early. And if you don't come on time, I will penalize you in marks, or I will get angry, I will shout at them, or I'll throw them out of the class. So this is a reward and punishment approach to making students learn about the importance of time, or being on time, discipline. So what is your opinion? It is a question of your philosophy of life. What is your opinion? This is a good method of training our students, or not a good method?
If some students are not too sensitive about the punishment, then it is a good thing. But if someone is very sensitive about the punishment, then it might go haywire for him.
Let me hear from others. Why other people are not speaking? Can I ask by name? On my screen, yeah, somebody wrote on the chat box. Positive reinforcement is good, in my opinion. So positive reinforcement means rewarding the behavior, a good behavior, but ignoring the punishment when this happens. So yes, actually it has been appreciated, and people have agreed that punishment creates negativity in the subjects, and therefore we should not rely too much on punishment. So it's not just a question of sensitivity. Now here, the question is, what is the goal? If my goal is only to make children disciplined, maybe that goal is fulfilled, but it may have side effects. It may create additional undesired behavioral changes in the child, which were not intended. So the child may become aggressive, for example. They say, there is a saying in English which to this effect, that says that if they fear you in your presence, they will hate you in your absence. Is that correct? Sai, you were saying something.
Sir, could you repeat again what you were saying?
Yeah, it says that if they fear you in your presence, they will hate you in your absence. How many of you agree? Those of you who agree, please raise your hands. Karthik agrees. Anybody else who agrees with this? Sai agrees. And those who do not agree, now can they raise your hands? So I can know who are neutral also. Those who do not agree. Sai, you had raised your hand on the earlier case when you agreed. Can you unraise your hand? So, okay. So this is a statement. This is a question. It is possible that people who are very afraid to speak out in your presence, they will speak out in your absence because their emotions are not being killed, and you are suppressing them. As a result, they might develop negative feelings towards you and towards life in general or towards people in general. So there may be the side effects and desired impact of this kind of learning. Now, since we are studying machine learning here, so let us relate it to the machine learning behavior. What is reward and punishment in the case of a machine learning?
We define a variable that has to be maximized, and if the result is closer to our goal, then we add to it, and if it is not, then we decrement to it, and the program has to maximize that variable.
Yeah, so it is your objective function.
Yeah.
That is that actually carries the information about reward and punishment. So you reward your model if your parameters are good. So your behavior is what? Parameters of the model. The trainable parameters are basically your behavior that you are trying to modify. So you're trying, as soon as you see that these parameters are doing as I want them to do, I say reward. So my error function will be reduced, or my object function can be positive if it is a positive error object function, if I'm maximizing it. And so reward and punishment is nothing but the object function in this case, which may be the error function or which may be a positive performance measure. So that is how the machines will learn. And now the equivalence of the behavioral modification of human beings is the modification in the model parameters that we are using. And what is the equivalent of human being here? So let's draw all the equivalents here. So we only drew the comparison between the reward and the machine learning model. Yes, Karthik's answer is in the chat box. So that says the machine learning model itself is the equivalent of human being. So machine learning model, for example, my regression model. So when I write a linear regression equation, this is my equivalent of human. And what is the behavior of this regression model? These regression coefficients that are associated to the regression model are the equivalent of behavior of that model. And what is the reward and punishment for this? But before reward and punishment, what is the data on which people are learning? Equivalent of experience or environmental changes is the data that is training data. And what is the reward and punishment, as we discussed, is the basically my error function, which has to be minimized. So there's a perfect equivalence between a machine learning model and this model, as we can see. Although when people discussed about these things, reinforcements, reward and punishment, they were not doing machine learning, they were doing learning, but the equivalence is quite clear. We'll keep on finding these equivalences and trying to see how we can improve this process. So second theory of learning, second group of theories have been developed by these scientists called John Dewey, Carl Rogers. So mostly in the late 20th century. So you can see that this is not as old as many of the things about intelligence we were discussing earlier. So that is based on humanism. That says, do not base your learning on the idea of reward and punishment. It says that all humans are inherently born good. And it is the job of the teacher or the learning environment to bring out that goodness and to cause the emotional fulfillment of the individuals whom you want to train. So the reward has been replaced here by another term, which is emotional fulfillment and the bringing out of the goodness from the individuals. And here, there are some concepts which will be useful to relate here. We'll see how they relate to machine learning, but a few concepts which are useful for anybody who involves in management and when you become employees. Have you any of you heard these terms, self-actualization or Maslow's theory? Do you study management, any of you? No. So anybody who has ever heard of self-actualization? No. So I'll quickly mention that Maslow was a scientist. He said that human beings have certain hierarchies of needs. We are born with certain needs. And needs can be our physiological needs. Needs may be the needs for being respected. Needs may be the needs for security. Needs may be the needs for being popular, famous, liked by others. And needs may be the needs of our emotional fulfillment. So I gave you a few, I did not separate these groups of needs, but Maslow separated these groups of needs. And if I can recall from those groups of needs, if I separate the physiological needs from the security needs, can you tell me which is more important for an individual? Physiological needs or the needs for security?
Physiological.
Physiological need. Can you identify what are our physiological needs?
Food.
Yes. So food and our physical fulfillment when we grow adults. So these are our physiological needs, as the researchers say. So when these physiological needs are fulfilled, then these needs are fulfilled at a given point of time. At that time, if our physiological needs are not fulfilled, if we are hungry, we will do anything. At that time, we have no other need. That is our primary need. All other needs will become secondary at that time. And we cannot teach morality to a person who is going totally hungry and are going to die out of it. So as Maslow says that these are our fundamental needs. But as soon as our physiological need is fulfilled, I get the food for today. I want to secure my food for tomorrow. So that is what security means. Security here does not just mean violence or thing. Security means ensuring that your needs are fulfilled not just today, but also tomorrow. So there come the second level of the hierarchies. And then when these physiological, the security needs are fulfilled, then we go to higher level and higher level. Then there is a need for being respected and affection, love. These are our next level of needs. So, and then in the end, he says that every individual, some of the individuals, in fact, have a strong need for self-actualization, where they want to be their best. Being your own best is the self-actualization. You want to become a good engineer. So you are very good. You feel proud that you are an excellent engineer. At that time, you do not feel important whether people are treating you as the best engineer or not. Mere fulfillment of your emotional goals of being your best is sufficient. That Maslow considers to be the highest need. And these theories are now implemented in management. When you run a company, several of you will launch startups. When you launch startups, then you have to reward your employees. And how do you reward your employees? How do you retain your employees? You have to understand their needs, and you have to make sure that their needs are being fulfilled. Sometimes you may be giving them a very high salary, but still employees will leave because their other needs, emotional needs or appreciative needs to be appreciated, are not being fulfilled. So that is why these theories have become important. And these needs are together called the humanistic, are covered in the humanism theories of humanism for learning, and they play our role in learning. So if my need is, if some of my tasks, some of my actions are fulfilling my needs, I'm trained, I'm taught to do that task again. So that is these needs. Our human beings want to learn and want to act in such a way so that their emotions and these needs are getting fulfilled. So this is not so critical for the machine learning, but this is more critical, more important for the management of your teams and management of your resources. For machine learning purpose, the third theory, group of theories I have called cognitivism, is very important. And you can think of many of the machine learning models that we see today may be related to cognitivism. So what it does, cognitivist theories of brain, they think of brain as an information processor. So they say that machine is nothing but like a computer, something like a computer that works on algorithms, and it develops and trains these algorithms and processes these informations to take decisions. Now, from the first group of behaviorism that we were talking about modifying behavior, and in the cognitivism, we are not trying to modify behavior, we are trying to talk about the ability to take decisions. When we studied intelligence in the beginning, we did talk about intelligence as the ability to take decisions. That means we are making our humans, through the process of learning, to act like intelligence so that they can take decisions that intelligent people will take. So a trained person may be better at taking decisions, even though he may not have a good intelligence. So that is the whole exercise of learning, is to behave like intelligent people in this context. So as probably I may have quoted again, then there's another quote that says, experience keeps a dear school, but fool learns in no other. Has any one of you heard this? And can you interpret what I just said? Experience keeps dear school. So dear also means expensive or costly. So experience keeps a dear school, but fool has no other way to learn. Can you interpret, can you elaborate what does this mean?
So can you repeat it once again?
So it says that experience keeps an expensive or costly school, or the schooling done through experience is an expensive one, but fool has no other way to learn. Can you relate it? Can you explain what this means?
Does it imply that the wise learn beforehand from others' experiences?
Yes, right. That is what it means, that the experience, sometimes we learn from experience, but if you learn from your experience, this is a costly learning. A smart learner will be one that will learn with few experience, with less experience, or as you said, from the experiences of others by observation. How would you translate this to a machine learning model? Which machine learning model will be wiser than others? In a similar way. Yes.
The model which starts from the data that has been used in other models beforehand.
So there is an answer in chat box. So which can learn from training of other models? No, I mean, here we are saying experience. So experience basically means data, right? So a good model, a wise model is one that can learn from less data, less instances. A high dimensional model which has requirements of less data will be considered to be wiser and will be considered to be inherently intelligent. But a foolish model, foolish computational model in this context will be the one you keep on feeding lot and lot of data, but the model is only incrementally learning. Only some changes in the error function are happening, but otherwise it is not learning. So even though your model may have a high complexity, many parameters to be trained, but still it is not learning. It may be because of slow learning rate, or it may be because of the inherent architectural problem of your algorithm or your model. So whatever is the reason, but when you say that the faster learning is the sign of an intelligent model, or that model which is efficient to learn.
So basically the ability to generalize based on a few data points.
Yes, but then ability to correctly generalize, because generalization may happen. You might have one point on a graph, and suppose you have two parameters, two-dimensional space, x and y, and you want to know the actual relationship between x and y, and you have just one point. So if you have a model which can draw a complex curve on this one point, may look like it is generalizing too fast, because the next point that you observe may not fall on the parabola or no, on the curve that it has done. So it may also imply the ability to learn too fast may also be an actually overfitting. But you are saying generalizing, that is correct. The term usage of term generalization is important here, not the learning, because learning on just the training data is not real learning. Real learning is generalizing, and it should be able to work in the same way on unseen data. So that's the challenge. Without having too much of data, how can you handle and how can you improve your models? So can you quickly give me a diagnostics? What kind of model should I use so that it can learn more from less data? Should I use a very high dimensional model, or should I use model with fewer dimensions, fewer dimensionality, or adjustable parameters?
A very high dimensional would tend to overfit, and very S would tend to underfit. So an optimum would be a middle one.
Yeah, so more complexity of the model means more data requirement. So, but again, the data requirement may also be guided by our training method, not just the learning model. So there are two things here. One is the learning model, such as I say linear regression model or a naive Bayesian classifier. These are our models. And then the question is the training strategy. How do you train? Meaning, how do I reach from my current state to a state where the parameters are correct, where the behavior has been corrected? So what is the method of learning? That also becomes important. So we'll come to those when we explicitly discuss those methods. So finally, this is also stated in terms of the terminology that has been used is that of schema. It says that actually the information that is stored in our brain is in the form of a schema. Our previous experience is stored in the form of a schema. And this schema becomes part of our long-term memory. So a schema is a kind of a framework. Do you know what is, well, of course you must know. Can you recall what is a schema in a database?
Yeah, it's like the underlying principle on which the database is organized, like relational databases.
So when you create a database, when you are given totally raw data and somebody asks you to create a database, first thing you have to do is to create a schema. And once you have created the schema and you have started populating your database, can you change the schema on the way?
No.
You cannot change that. Once you have database, you have created a database, you do not change the schema. So a schema is like the structure in which you will put your information. So if it is a matrix, for example, the columns where you are writing all the attributes are the schema. It may be tabular, or it may have a hierarchical representation. So the schema represents the names of the attributes, the types of the attributes, and the number of attributes and the structure of attributes, whether there is a parent attribute and the child attribute. So all this forms the part of the schema. And that is how we organize the experiences around us in our brain. So we can change the schema, but need to migrate the data accordingly. Yes, of course, when we change the schema, then it essentially looks like a new database, although the information is the same. So we have to migrate it. So changing of a schema is a fundamental change to the database. But you cannot incrementally, as far as standard practice of database is concerned, you cannot incrementally change the schema while you are populating the data. So if you start populating the data in a new schema, you will first modify the schema and then start populating again. So this is like a new version of the database may have a new schema, modified schema, or migrating it. Is that correct, Karthik? That is, or is there something that I'm not picking up correctly from your comment here? Yes. Okay, thank you. So now we come to the question that Aditya was raising earlier, that when we get some new experiences, these experiences may not fit our existing schema. And that is the question of how we change our, when we receive new information, what do we do with this? When new experiences come, in terms of my schema, what do I do? So these theories, actually Piaget was a scientist who was actually a physicist, I think originally. He worked a lot on the development of child development and the intelligence development. And a lot of work has been associated to him. You can read a lot about what kind of actions we can do at the age of 3, at the age of 4, the formal thinking and the concrete thinking. And there are many interesting things which will be which may be useful and maybe interesting reading as itself. So there, the idea is that when new information comes, this information can be, in the easiest manner, it will be assimilated. And assimilated means you put it in the existing schema. This is called assimilation. So same as in a database, you get new objects or instances, you attach those new instances and objects into your existing schema, your database grows. So this is the process in our brain, that we have a certain schema in our mind. We know, we have the definitions of people, like our relations, our father, our mother, our sisters, brothers. So when we meet new relations, we put them, okay, this relation is my uncle, this relation is my brother, this relation is my such and such teacher or whatever. So these relations I put. So new information comes and I interpret them and store that information in the form of, in the schema that already exists in my mind. But many a times I will encounter situations when my new information that is coming is not fitting my schema. It is, it looks like a totally new thing, new concept. And maybe, for instance, the idea of the father and mother or the teacher or a spouse that you have in our culture may be different. Maybe we might be in a new culture and new types of relationships are seen. So they do not fit in our schema. So when they do not fit into our schema, they cause what is called disequilibrium. That the psychologists use this term disequilibrium for this scenario. So under this scenario, either we get upset, it causes our stress to our brain, or we try to improve our schema. We say, okay, this also exists. These things also exist. So that kind of a framework, the schema has to be modified. So that is this process of modifying your schema or adjusting your schema according to the environmental changes. This is called accommodation. So this happens to a child when a child is learning from the early stage. He's learning many new things. Child does not have the concept of father in the beginning. Child does not have the concept of mother in the beginning. Over a time, when the new environment comes and the new information comes, child learns about what is the meaning of father, what is the meaning of mother, what is the meaning of friend, and what is the meaning of teacher, what is the meaning of other things. So that is how they keep on accommodating. And in the process of accommodation, the schema gets modified. This is called, in this terminology, and this theory, which is based on this idea of assimilation, accommodation, and basically assimilation and accommodation. Accommodation as a consequence of disequilibrium, or if it does not happen, it leads to stress. This is called constructivism. Constructivism. And this, in this process, it is not just we are modifying our behavior, we are also creating new knowledge. So individuals create knowledge and meanings to that knowledge through their interaction with the world through these processes. So these are another way to look at the learning process, the machine learning and intelligence, and how the intelligence grows. So this is the pretty much what I wanted to kind of take an overview for the machine learning from these theories of learning. And when we actually look at the models, now when we study machine learning, we are actually learning different models to do the same thing. And now the task of machine learning, to understanding machine learning, is why should I use one model over the other? What kind of experiences can be modeled by one model, such as machine learning, such as linear regression or Bayesian? What cannot be done with this, and what kind of models, what kind of data or experiences can be fitted onto a random forest or onto a decision tree? What kind of experiences on data can be fitted on a multi-layer perceptron? And what kind of data cannot be fitted on multi-layer perceptron, and perhaps CNN or deep learning models will be more effective? And why? What are the internal structures of these models which make them suitable for some kinds of problems and not suitable for other kinds of problems? these are the issues that we'll discuss in the next few classes. And before I close, I can take some more last questions if you have any.
So as of now, we follow the cognitivist.
Broadly speaking, cognitivist theory and reinforcement. We already introduced the idea of reinforcement in the form of reward and punishment. We found a perfect equivalence between the idea of reward and punishment to our object functions in the training. But all our learning methods are not based on that.
But what I have seen that is that most of the reinforcement learning happens when we train AI to do very in games, where the environment itself is a very rewarding sort of scenario.
Yes. Yeah, so that is the equivalence here, reward and punishment and associated with the reinforcement. So we'll come to that, but in the first few classes, we will look at what are the options. How do we, what do we mean by learning, and what is the goal? How do we take experience and choose a model? Why not use a simple linear model? And when can we do linear modeling? What is the difference between linearity and additivity? And how our models add up the information? And so these are the questions we will look at. So rather than just looking model one by one, we try to look at the philosophy of these models and try to do a reflection why this model is suitable in this scenario and it is not suitable in this scenario. So the kind of decision surfaces for classifiers, the kind of pattern surfaces or the pattern geometries, implicit geometries, explicit models, and the implicit models, where you can explicitly see that this model is trying to, how this model is trying to learn. And implicit models where you do not exactly see what is going on because what is going on is too complex to be interpreted. And then the idea of explainable AI. So we will cover those to some extent in the coming classes. All right. Thank you then. And thank you for your participation. See you soon.